Welcome to Praveen Patil, College of Diploma Engineering and Technology. Myself, Raj Gheware, working as a lecturer in Mechanical Department. Today, we will be looking on the subject Theory of Machine. So, in this part of the video, we will be looking at the further topics, that is inversion of single sliding crank. We can also say it as Whitworth quick return mechanism. So, in this Whitworth quick return mechanism is used in shaping machine. It is obtained by affixing the link to which act as a crank. Purpose of this is desirable to reduce the non-productive time in machining, so we use quick return mechanism to let the backward stroke operate at a high speed than forward stroke. Now in this, the driving crank link 3 CA rotates at uniform angular speed. The slider, okay, so this slider of this diagram, the slider C, which is acting as the end of the driving link 3, is also slided, reciprocated in a slotted bar and curves to rotate the slotted link about a pivot B. Now over here, with the Whitworth quick return mechanism, when the driving crank AC moves from the position AC1 to AC2 through an angle of alpha in clockwise direction, so the tool moves from left hand end of its stroke to right hand end through a distance. Now if we want to measure the timing ratio, so what we are going to do is timing ratio will be equivalent to time of cutting stroke divided by the time of return stroke. Also we can say as angle turn during the cutting stroke divided by the angle turn by the crank during return stroke. So from this second diagram, we will be clearly able to understand how this Whitworth quick return mechanism is been taking place. So here what happened, this is acting as a rotating member, this part is rotating and it has been fixed through this linkage, okay, that is for we can call it as a lever. Now it has been further connected, that is from this point, this C to D is the point of this green point of the diagram. Now it has been further connected to the piston, okay, or else we can say at the tool post. Now here when the tool advances further, okay, so when the tool advances further, it is nothing but the time of cutting stroke. When the tool advances further, at that stage the tool is performing a cutting stroke, and the quick return mechanism, we are able to see the quick return mechanism, how this here, how the mechanism is returning back. Now right now it is moving forward and again see quickly how it comes back. So this is all about the Whitworth quick return mechanism, which has been obtained from this, which we are able to understand from this second part of this diagram. So now we will be looking at the further part, that is oscillating cylinder engine, third inverse. Now in this oscillating cylinder engine, in this mechanism link 1 is fixed, the driving crank 2 rotates from a fixed point O1, the piston rotates and a slider P from 1 link 3. Now the oscillating about pivot point O, when the driver crank is rotated about a pivot point O. This mechanism is used to convert rotatory motion into oscillating motion and is obtained by fixing connecting rod of reciprocatory engine mechanism, as we are able to see from the diagram itself. Now let me just name out some points. Okay, so let me consider this as the O point, this as the C point, and this being the O1 point. This point will be the O1 point. So we can see that in the mechanism, link 1 is fixed. The driving crank 2 rotates about a fixed point O1. The piston rod and the cylinder P forms one link, that is link 3. So the from this upper part of the diagram we can able to understand how this oscillating cylinder engine works. So when the crank rotates, so the piston will tends to move forward or backward direction. So because of the movement of this cylinder, because of the fixation of this cylinder, because of this such arrangement, the cylinder now tends to oscillate in upward or downward direction. So this is how the mechanism of oscillating cylinder engine takes place. Now let's see about the double sliding crank mechanism. So in this we will look at the first one, Scotch yoke mechanism. So before we see to this, we will firstly see the last part, that was of a pendulum pump. Now in this pendulum pump we are able to observe various linkages. Now here this is the cylinder which we consist as a link 4. So this is also a cylinder, this is a link 4. Let me just highlight the part. Okay, so this cylinder is the link 4, this is also the link 4. Now over here this is acting as a connecting rod, that is given as the link 3rd, and this piston, this is a common rod for a piston. Let me just highlight the piston rod itself. So this is a piston rod which is making link 1, and this is the part of a crank which is making a movement, semi-rotating movement, not a complete rotating movement. We can say it as a semi-rotating movement. So the path is traced like this. Okay, little curvature is formed over here, and this is the connecting rod which is being used to connect the both upper as well as the downward part of the piston. Now as this crank wheel tends to rotate, that is as this crank wheel tends to move in the upward direction, so the piston from the down wheel tends to move upward. So the piston from the down wheel tends to move upward, as well as the piston which is present above in the cylinder will also move in the same path, in the upward path. And the trace path of this crank, that is this part, is being traced over here. It is performing like a semicircular part. It is performing, the path is like a curvature path. So from this second part of this diagram we can clearly able to understand the pendulum pump, that is fourth inversion of the inverse of a single sliding crank mechanism. Now from this we can see how the piston is being moved upward as well as in downward direction, and through the crank, the yellow part of this is the yellow part, this is the yellow part. Okay, so see how this is acting as a crank. Now how this crank is moved in a semicircular path, and how this path is being traced out, and how the movement of this is converted, semi curvature movement is been converted into reciprocating movement of both of these piston. So this is all about the pendulum pump, and in the further part of the video we will look on the inverse of double sliding crank mechanism, that is Scotch yoke mechanism. We will be seeing this mechanism, and from the second part of the diagram we can clearly understand the mechanism of this. So we will see this further mechanism in the next part of the video. So that's all for this video. we will be stopping at this pendulum pump mechanism. Thank you.